So this is a bit of a mouthful, but just to start off, so I want to talk about the UXL Foundation in the context of using open standards, using open source to make highly parallel programming on CPUs, GPUs, and different types of accelerators as well. So first of all, just kind of want to, I suppose, frame where we are within the industry. A few years ago, this term heterogeneous programming was something that I think, was quite a new terminology, and maybe even now people don't really understand what it means. But effectively, all that means is that rather than traditionally when you were developing software and you were just running things on a CPU, it effectively just means that you're choosing to run your workloads on different different processors, so CPUs, GPUs. We've also got things like MPUs. Google's got TPUs. There's all sorts of different things. So there's a couple of charts that I've put up here. One of them shows some research that's been done around graphics card shipments. And really what this is showing is that there's an increasing number of suppliers for GPUs. So there was kind of a big spike quite a long time ago, and then it went down to a small number of organizations, and that's kind of growing again. So it's kind of showing that there is an increasing interest in GPUs, and I think a lot of that is potentially being driven by Chinese manufacturers, but also by advances in AI and using those processors for different types of workloads. The other survey that's shown on the right is by Evans Data, who are a developer marketing agency. They do surveys with developers, asking them how they use things and what they work on. And this survey, which is a little bit old, is showing that this multi-architecture programming that we talk about is becoming the norm. So more than half of developers are using GPUs alongside CPUs. So I guess following from that, when I was at the ISC conference this year, we held a BOF there for the foundation talking about open standards in HPC. And you can see here that the respondents that were there, there was more than 80% of them that are now using GPUs alongside CPUs. So it's an obvious trend that's happening. And this is really where the UXL Foundation's been formed to try and help with this transition. So if all these developers are using CPUs, GPUs, FPGAs, MPUs, and things like that, then how are they doing that and how are they programming it? And there are a bunch of proprietary ways that you can do that at the moment. Most GPUs, you have to program differently for those. So we're trying to address that by enabling you to use open standards to APIs to target these different processors. So the UXL Foundation, so we're part of the Joint Development Foundation, which is under the Linux Foundation. We were formed about 1.5 years ago. And as I say, this was born out of a project that Intel had predominantly been working on called One API, where it had a specification that defined cross-platform APIs alongside a bunch of open source implementations. And what those projects allow you to do is to target different processor types, depending on what you want to use. So this is the mission, which is kind of a usual kind of slightly wordy mission for the foundation. But these are the things that we're trying to achieve. You can read yourself, but the keywords multi-architecture, multi-vendor. I like to use the term vendor neutral as well. We're trying to unify everything around open standards, define those APIs, and we're building upon open source the fundamentals of that. I guess the one thing that's changed a little bit is we're focusing sort of beyond the traditional HPC environments, so research clusters and everything else, and looking at how we can deploy the same things across those, but also edge environments mobile devices or, I guess, less powerful computers that you might use in an edge environment. To kind of cut through the long wordy thing, I suppose these are the three things that I think we're trying to achieve here. The first one being that we don't want you to think about the hardware that you're using. We want to make your code run fast and in parallel and easily. And we want to use open standards and open source software to do that. So just to talk a bit about the projects that the foundation governs, these are C++ libraries, and they're trying to cover the building blocks, as you might say, or the fundamentals that you might need as a developer, to write accelerated software or to accelerate your software, really. There's a DPL library, which is a parallel C++ library, so that implements a bunch of the ISO C++ parallel routines. So you have things like parallel sort or ranges and things that are implemented in ISO C++, so that implements that. There's a DNN library that you can use for Euro network development. The CCL library is more focused if you have a multi-node environment. So you have a sort of cluster of computers on different nodes, then it allows you to distribute that work across those. OneDAL, which is used for, I guess, sort of data analytics processing, and you can use that with scikit-learn, which is quite a commonly used framework for machine learning. 1TBB, which is a CPU library, but it basically allows you to easily multi-thread your program using quite a simple API, so you can make the most of all the cores that are on your CPU. And the last one, which is actually now called OneMath, but historically it was called OneMKL, is a math library that allows you to call functions for things like BLAS, linear algebra, but also like random number generation, things like that. I'll talk about them a bit more later. So these are the organizations that we brought together within the foundation. We have some of our steering members here today from GE, ARM, and Qualcomm, but we also have representatives from Fujitsu, Google, Intel, Samsung, and Broadcom as well. We have growing number of contributing members, and as you can see, there's kind of a range of software and hardware companies that are in there. And some of these are kind of focused on RISC-V, which, again, another Linux Foundation project. We want to help them to bring a standards-based programming environment for their customers in the future as well. This is what the governance looks like. So as I said, we're a joint development foundation project. Basically, that means that we're using like a templated governance environment so that we can define APIs and things like that using a standard agreement that everyone signs. We have a technical steering committee that meets every fortnight. Steering members bring a representative onto that, and we help to sort of guide the UXL Foundation in terms of the activities that we're doing, what we need to be looking at in the future and things like that. The interesting groups probably for you are we have special interest groups that I'll talk about in a bit more detail, but they are more informal knowledge sharing groups that anyone can join. They cover some different areas around AI, hardware enablement, language, and maths specifically. I guess the key thing is that all decision making is done by consensus or through a majority vote. So just to talk a bit about, in a bit more detail about what kind of domains that we cover within the foundation, these C++ libraries. You can see that there's the math library, so that covers linear algebra, so things like BLAS that I talked about, random number generation, DFT, These are the sort of things that you might use in a big science application, but also in other areas, finance and yeah, they're meant to be generic routines. The DNN library provides like optimized high performance routines for a bunch of things that you would use in a neural network application or framework. So the sort of things you'd expect, a lot of matrix multiplication, convolutions, these are the sort of things that you need to use in order to process these kind of things quickly. OneDAL so covers deep learning analysis. I talked about scikit-learn that sits alongside that. OneCCL, the DPL I talked about, the C++ parallel routines, so it implements things from C++ 17 and parallel STL, and some new things from C++ 20 as well. And I talked about OneTBB, which really just allows you to easily make your software run faster on a CPU. I'm going to talk about this a bit later, but there are various ways that you can get involved, the usual sorts of things that you would expect from open source projects. And anyone can join the foundation. There's different levels of membership. You can join for free, so that's something that's very very easy for you to do, and it's as I say, it's a standard agreement. Right, okay. So we can switch over to the next section if you're ready to go.